Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing advantages of negative feedback. Let us quickly review the advantages. First one is stability of gain, reduction in distortion, reduction in noise, increased bandwidth, increased input impedance, decreased output impedance. In our previous class we have seen stability of gain. In this class we will be seeing about reduction in distortion. So as you know, this is the block diagram of negative feedback amplifier. An amplifier of gain A and a feedback network of ratio beta, and where the function of this feedback network is to take a part of output and send back to the input in opposite phase with the incoming signal. So let us say the incoming signal is XS, which is shown with the polarity plus sign, and XF is a feedback signal which is the part of output voltage. If you designate the output signal by X naught, XF will be equal to beta times of X naught. So XF will be beta times of X naught given to this mixer circuit in opposite phase, which is shown by the minus sign, and the input going to the amplifier is designated by Xi, which is the difference between Xs minus Xf. So this is the block diagram of negative feedback amplifier. And when we derive the gain equation of this complete negative feedback amplifier, the gain equation is coming to be as AF is equal to A by 1 plus A beta. A is the open loop gain, beta is the feedback ratio, and AF is the closed loop gain. Open loop gain, closed loop gain. This A is the open loop gain, and AF for the complete circuit for negative feedback, it is designated by AF. Now let us see how the distortion is reduced in negative feedback. Reduction in distortion. It will be very easy to understand graphically. Let us see these three graphs. So now we have understood what is Vi. Okay, Vi is the incoming signal to the negative feedback amplifier, and Vf is the feedback signal, and Vi dash is the difference of Vi minus Vf, that is output of the mixer circuit at the input part. We have seen this diagram. Let us say that an amplifier of gain A feedback network of ratio beta, and there is a mixer here. This is Vi, Vf, and this is Vi dash. This is V naught. Okay, so how those waveforms will be? This is the diagram of a negative feedback. So let us assume that this is the Vi input signal of this nature. And now what happens? The feedback signal, let us assume that it appeared in this form, that is in the distorted form. Some part of the peaks are clipped off. Let us assume that this is the feedback signal appearing. Now when we take the difference of these two signals, how it will appear? It will be appearing as a smooth waveform. It will not appear like this. Clipped peaks will not be appearing. So it is somewhat more smoother compared to without feedback. If we have taken without feedback, it will be highly distorted, whereas when we take the difference of the two signals and then amplify it, it will be coming in a better way. So it is a smoother signal. So after applying negative feedback, we get less distorted waveform. So that's been written in words here. In negative feedback, the harmonic distortion is reduced. This can be shown in the graph here. This is a harmonic distortion which is exhibited here. Vf is the distorted. Vf is distorted since amplifier output is distorted. A flattened output when subtracted from the input becomes a resulting output V naught dash of the more peaked. Thus the net input Vi dash is pre-distorted in such a way so as to partially compensate for flattening caused by the amplifier. So now let us understand it mathematically. we have seen it in the graphical form how it is reducing the distortion in a negative feedback. Now let us understand. In this diagram, if this is an amplifier without feedback, it is producing a distortion of D. Now we have drawn this is negative feedback. When the feedback signal is in opposite phase with the incoming signal, it is known as negative feedback. This is a negative feedback amplifier. Let us assume the distortion produced by this circuit is DF. Okay, so due to negative feedback, what this feedback network is going to do? It will take a part of output. Let us say this is the distorted output. So it will take part of distorted output, D beta times of DF. Okay, now it is giving to this signal. Now what will happen? This signal, after coming with this encoded signal and getting subtracted, let us say this is Vi and this is Vf and this is, let us say this is Vs, this is Vi. Okay. So now what will happen? Now along with this feedback signal, the desired signal is coming anyhow Vs. Along with this desired signal, there will be this part also will be appearing. So what will happen? Now this signal is amplified by the amplifier A. So what will appear here now? A times of beta DF. Okay. So what will be the output now? It will come as DF is equal to, how much is DF now? DF will be equal to capital D, that is the original distortion without feedback, minus A beta times of DF. So take DF term common, 1 plus A beta, which is equal to D. So how much is DF now? DF is equal to D by 1 plus beta. So what happened now? This DF is what? Distortion with feedback. And D is distortion without feedback. So now DF, this capital D is divided by some value. It means DF will be definitely less compared to your D. Yes or no? This is net distortion. So it will be reduced. So in this way we can say that distortion with feedback is reduced. Okay. So this gets this is how we can prove it mathematically, that in negative feedback the distortion is reduced. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.